Greetings, good morning, good evening. This is Mr. Lowe's. We're going to go over how to measure objects when it's going to be a little bit difficult to measure them otherwise. So you guys can see behind me here, I have a light, and I'm curious to see what size ladder I would need to reach up to the top of that. So there's a few things we're going to do. I have a altimeter reader here, an altitude finder. So I'm going to use that to kind of measure what's the angle. And if you guys remember that formula, cosine of A is equal to the side opposite of angle A divided by the side adjacent to angle A. So we need to figure out the angle up to the top of this light here, and we need to figure out how far away we are from standing from it. So we need to figure out a baseline, and we need to figure out an angle. And I'm going to go back and show you using a formula how to calculate the height of this. So right back, hold on. Okay, welcome back. I'm in here just outside of RCMS. Got a whole bunch of stuff here, cars, everything all by myself. Nice, peaceful. I can hear a bird chirping in the background. Got my pen, paper, got my altitude finder. And how this works is we have a series of degrees here, starting from 0 and going all the way up to 70 degrees. So hopefully where I'm standing at is not too high. I may have to back up if this doesn't work. So first thing I'm going to figure out, I'm going to stand right here at this corner. I'm going to measure the light pole up there and see how high it is. So what I'm going to do is I'm going to pull on this trigger here, and that's going to release my swinging mechanism on the back. Hope you guys can see that. Yeah. When I let go of the trigger, that's going to stop it from swinging. So I let go of the trigger, doesn't swing. Pull the trigger, and it swings. Okay. So I'm going to measure up here, and this one's broken, but I'm going to kind of center it to the top of what I'm measuring. I'll let go slowly with my finger, and I got a measurement of, there we go. You can see that 40, we're going to go 48 degrees. Looks like they're going by twos. So my cosine of A, I don't think you guys are seeing that, maybe, yeah. Cosine of A was, okay, I'm back out here at the light pole. So I'm going to measure from the corner that I was standing right here to the light pole. 1, 2, 3, 4, 5, 6, 7, 8. And it's going to be about 9 to get to that light pole. So let's go in, figure this out. I'm going to introduce you guys to trigonometric ratios. And we're going to figure out what is the height of this pole in the example that I do in class. I'm going to use that measurement that we found. I'm going to use this baseline that we just found. So baseline is from here to the light pole. Alright, see you guys in a little bit. Okay, so later on in the video, I referred to trigonometric table for table values here. And what we want to be looking at is we measured 48 for our angle. And so this is the line that I'm looking at. And for the trigonometric ratio for tangent, here's our tangent. And so we looked at this specific number here when we get to our example. Okay, now one more thing. Also, note on that last part of the video you just watched, you heard me walk, and I took 9 steps. And so 9 steps roughly translates into about 3 feet per step. So 9 times 3 is 27 feet. So later on when I get into that last example, when I put down the 27, it's because I took those 9 steps. Okay? See you later on. Greetings, good morning, good evening, good whatever time it is. This is Mr. Willis checking in. We're going to be going over trigonometric ratios. And we're going to be using trigonometric ratios to help us calculate the heights of objects that we cannot so easily measure. So to do this, just going to kind of go over a little bit of the background of a trigonometric ratio. I'm going to read this through, pause it if you'd like to ahead of time, and then you can hit play, listen to me read it, and then move on. So a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. The three basic trigonometric ratios are sine, cosine, and tangent, which are abbreviated as sin, cos, and tan respectively. Okay, again, as needed, please pause this. Okay, these ratios only work with right triangles, so you must have a right triangle for this to work. Okay, so I've drawn up an example here of a right triangle. The key things here to recognize is how it's set up. So for this angle A here, I am referring to this angle, the measure of the degree from here to there. Okay, so that's angle A. And what always happens with, so if this is angle A, the side opposite of it is labeled little a, which is side length A. Okay. With the angle B, okay, it's a measure from the top there, okay, I'm right there, the top going down to there, and the opposite of capital angle B is the little b side. Okay. And let me erase this now. Kind of get rid of some of the junk in the middle there. And then the third side is, or the third angle is capital C, which is this right angle. And opposite of the right angle is always going to be the hypotenuse, which is the longest side of a triangle. And it's labeled as little c. So you have the big angles are labeled as or the big letters are labeled as the angles. The little letters are for labeling of the sides. Okay, and then when I'm referring to angle A, again, let's go back to angle A. If you look here in the blue, side adjacent to A. So the side that's adjacent to A is this bottom one here, because it is right next to angle A. It's adjacent. Okay, and then over here on the far left is the side opposite of A. It's completely on the other side of A, which is why it's called little a. Okay, and then always, for all right triangles, the longest side, which is always the side opposite of the C, is labeled as the hypotenuse. Okay, and the trigonometric ratio that we're going to be working with to find our heights on all these is going to be this trigonometric ratio here, which states that the tangent of angle A is equal to a ratio of the side opposite of A divided by the side adjacent to A, which is just the little a divided by the little b. Okay, so side opposite divided by side adjacent. Okay, so let's manipulate this slightly. Okay, so the tangent of angle A, which is it's a relationship between the side opposite of angle A divided by the side adjacent to angle A. So it's simply one number divided by another. What we have is we have a given set of trigonometric ratios, which can be found in the back of most math books. Once you get into algebra, pre-algebra, geometry, any of those higher upper level math books. So starting with your math book this year, in the back of it, we should have a set of trigonometric ratios. Okay, so let me manipulate this a little bit more. What we're going to be doing is we're going to be taking the height of an object. So let me just draw, let's say this here, let's do a light pole. It's emanating light here. Okay, and we stand some distance away from it that we can measure, because it's down here on the ground, we can measure that. And then we're going to take one of us, I failed stick figure class, so let me try this again. Okay, I had to put some ears there so you'd recognize me. And what we're going to do is we're going to measure the angle up to there. So we're not going to measure that length, we're going to measure the angle from the ground using a altitude finder all the way up to the top there. So this is going to be angle A. Okay, we're going to be able to measure what we don't know is the side opposite, which is a little a. What we are going to measure, though, be able to measure is this side adjacent, which is we're going to label as B. Okay, so the tangent of A, let's say that came out to be 48 degrees. So tangent of 48 degrees is equal to a relationship of whatever the length of A is divided by the length of B. And let's say we measured B to be, let's run a number here now, B equals 27 feet. So if we're 27 feet away, we can then go and measure, we're going to look up the tangent of 48 degrees. So the tangent of 48 degrees, I'm here looking at my table in the book, and we have 48 degrees, sine, cosine, tangent is 1.106. 1.106. So when you evaluate the tangent of 48 degrees, you're left with 1.106. That's equal to whatever the value of A is divided by 27. Okay, so I'm going to take all this now. We group it together. Copy. I'm going to work with this on the next page now. Copy. It's not letting me take that. 1.106 and 27. Okay, so here's our formula. And now we're going to take A and we're going to solve for A. So to solve for A, we're going to use inverse operations. So instead of dividing by 27, I'm going to multiply by 27. Same thing over here. Multiply by 27. And what's going to happen here on the right side is you have 27 over 27, which simplifies down to 1, which is what I wanted. So you have the value of A left equals, and then we got to do 1.106, multiply that by 27. 6 times 7 is 42. 7 times 0 is 0, plus 4. 7 times 1, 7 times 7. Got a holder there. 6 times 2 is 12. Carry the 1. 2 times 0 is 0, plus the 1. 2 times 1, and then 2 times 1 again. Add these up. 2, 6, 8, 7, 8, 9, 2, and we multiplied with 1, 2, 3 zeros, 3 decimals, so we go back 1, 2, 3, and we get 29.862. So going back to that problem, let's do 29.862, and I'm just going to round that to the nearest tenth of a foot, so it's about 29.9 feet. So close to 30 feet tall. So going back to that light pole, this here value would be the 29.9 feet. So without having to get up and get a big old ladder, measure from the ground to the top. Most tape measures only go 25 feet, so I have to measure that twice. I can use this trigonometric ratio and quickly find about approximately what the height of that light pole is going to be. Okay? And so let's break this down with what we just did even further. So the tangent of any angle that we find is equal to the ratio of the side opposite divided by the baseline. And once we found that problem, what we did is we multiplied by the B over 1. We multiplied this by B. And this was whatever number B turned out to be, canceled itself out, and you're left with 1s. And so we're left with this equation here. The tangent of the angle multiplied by B, which in this case, in all these cases we're going to do, is we're going to call it the baseline. It's that side adjacent to it, is equal to whatever the height of the object is that we're measuring. So all I need to really keep handy with me is my table of trigonometric ratios, so that I can, whatever angle I find for A, I can measure that. I can write it down and then just multiply it by how far away it is. Okay? So this is the formula that we're going to be using over and over and over and over. Tangent of A equals baseline, or tangent of A multiplied by the baseline is equal to A.